Okay, Victor Momo from Excel Moments here, and I want to show you a dynamic solution to consolidating multiple tables in your workbook. This can be extended to maybe not just tables, they could be regular ranges, but well, we'll see how it plays out. I have shown a similar solution to this in one of my other videos, but this is slightly different and you'll see the difference. So what I have here is I have a long list of tables I have in this workbook. Okay, you can see store 1 to store 4. The 4 of them are on this worksheet. Then you have 4 other tables in these 4 sheets here, A, B, C, D. What I want to be able to do is consolidate data from all those tables. But rather than just consolidate for all of them, I want to have a control here where I can choose which ones I want to have added, and which ones I don't want to see. So once I do a yes, then I want it to be added to my consolidated table. So take this for example, you can see I have store 3, store B, and store D. That's because those are the 3 of them here that have a Y in the include column. So if I change this, for example, to an N, okay, then you see that I have only store 3 and store B, right? Because those are the only 2 with yeses. So how do you set this up? Let me lay a little background, then I'll come back and walk through the formula solution together. Okay, so here's the idea. So you have, let's say in this case, like 6 tables, right? Ultimately, what you want to see is something that looks like, this, right? Where you have all the tables stacked. Okay, so if you want to achieve this with a formula where you want to see maybe the individual elements, meaning that at every stage of the stack, you want to see, oh, where am I now? I've stacked 2 tables, I've stacked 3, I've stacked 4. Then you use a scan function. For those of you that have watched my videos, you realize that I like to start from the scan and then transit into the reduce. Kind of makes it make sense. Okay, so what I've just done here, to make it visually work is just to use a character 10, to create that effect of or illusion of it being stacked. But you won't use character 10 when you're stacking up the tables, right? You're going to use a VStack because a table is not just a value, it's like a 2D range, right? So let's start up with a scan and see how we can get these individual elements. Okay, so I can start up with a scan function, right? Initial value, I say, okay, maybe I don't know what my initial value is. Now, what's my array? I take all the tables, which is like here, A to F, okay? And then I go into the lambda portion where I then write the function I need. So I have, an accumulator and I have an iterator, right? So what do I now do with both of them? In this case, because I'm just using character 10 to create, multiple lines in one cell, I'm going to use character 10 and say accumulator and, character 10 and iterator. So what does this mean? It means that you're going to start off with the accumulator, which first value is always the initial value, which here is nothing, right? Then it's going to stack it up with whatever the iterator value is. Now, what are the iterator values? The iterator loops through this array that you've given it B2 to B7, meaning that the first value for the iterator is A. So now, since you said, accumulator has an initial value of, let's say, nothing, then you stack that, with A. So your result is like more or less like nothing and A stacked up. Okay. Now, that new value is what the accumulator will take in the second loop. So now you have your accumulator having the value nothing and A. Your iterator has already used the value A. So the next time iterator is going through, is going to pick B. So now you have nothing, A, and B, and so on and so forth. Let's see what it looks like, easier to see when you do it. Okay, so now you may notice something already, that on top of the A, you are having a blank because you started with an initial value, right? I mean, I can fix that if I choose to fix that, okay? But I can decide to do this. If I just take this out, then that pretty much changes everything. Okay, so I can see A, I can see AB, ABC, and so on. But in reality, I'm not interested in any of these intermediate values. I'm only interested in the last one. So once you're interested in the last value from a series of, steps, in this case, you just change the scan to reduce. So reduce is not bothered with all the intermediate values. It just gives you the final value. So change this to reduce. And now let's expand this column, or row rather. And then you can see all the values you have. So with a reduce and this construct, we can have all the tables stacked up together. That's the idea we want to use in here. But this is going to be a little interesting. So let's start up. The first thing I would like to know is, which tables am I interested in? From what you see here, you know that the tables you're interested in are the ones that have a Y in the include column. Someone may choose to include all of them, and then while you're looping, you now check, oh, is this column Y, and then you decide to add that table or not. But what I would prefer to do is to use a filter function, which is filter this table and give me just a list of tables that I need. So what I mean is I'm going to filter this table where the include column is Y. So let's start with that first of all and see what that gives us. So do like a filter, and here we are filtering, on the table names where the include column here is equals to what? Y. That's pretty much what it is. So you can see that we have store 3 and store B. If you change this now to a Y, okay, you now have store 3, store B, and store D. So this, in effect, is what you are really looping through, right? So even though there's a bigger table, but this is what you're going to loop through. So let's just work this out by putting a let. Let's make this a variable, and let's call this maybe TL, like a table list. Okay, so that's our table list. And once we have that table list, we can now choose, to loop through tables and do whatever it is we want to do. So we're going to use a similar construct to what I did on the previous sheet. So let's go into the reduce portion. I can start the reduce, with nothing pretty much. So more or less like blank. Then in terms of the array, what am I looping through? I'm looping through all those names of those tables that have a Y in the include column, which I have already defined as a variable TL. So that's TL. Ready? Okay, good. And now we go into the lambda portion, right? So we go into lambda. Lambda has two variables. I call this the accumulator. I'll make that A, and I call the iterator B, where B is going to loop through all those table names, right? Okay, so now let's now do the calculation. So what is the calculation we're going to do? The calculation is really to stack the tables on top of themselves, right? So it means that we are going to use what? A VSTACK. Okay, and the first thing you're going to have is your A, right? Your initial value. Then you stack it up with the B's. The B's are the table names. So you then say, oh, okay, stack up with store 3, stack up with store B, stack up with store C. But now, the important thing for you to note at this point is that what is stored in, the B, which is this your TL, what your iterator is going through, are the names of the tables, not the data in those tables. So if I say this table is named store 3, right, that's just the name. But if I need to get the data in there, I can then use indirect of store 3 to then pull out the data. So what I'm really stacking with in the real sense would be stacking with indirect, of B. Okay, so let's take that first of all, then we will just, build it up gradually. So that's the reduce and this the let. So let's see what that looks like. Okay, don't mind the headers for now, I'll fix that. Okay, so you can see that I have, some data. But again, to be sure that the data is the right data, I would like to include the store names, which is like the table names, to be in the first column so that I can really see that, yes, it's actually giving me the tables that I said I wanted to have. So what I'm going to do is I'm going to put, an H stack and say stack up the name of the table with the data in the table, meaning that the first column here would be the name of the table, then the other columns would be the data in there. So in here where I have this indirect of B, what I'm going to do first of all is I'm going to put, an H stack, and I'm going to stack B, which is the name of the table, with the data in the table. Okay, so let's close one more bracket. So it looks something like this, right? Okay, so now we're getting closer. One thing you would see that would be very obvious is that we have a redundant first row, and that's because we started off by saying, the initial value here, it's a blank, right? But it's going to create a row based on that. So what we could do to fix that particular one is to do a drop, and say drop that first row. But before I do that, I may want to fix the NAs. You notice that it's only the first row of each table that has, the table name. The others show a hash NA. So what we can say is that if it's an error, meaning that if it's NA, then give me the name of the table. So in here where I have this H stack, I come back again and then I do if NA, right? So if NA, what do you want to see? So you need to locate where that's coming in. That's here. If it's NA, I want to see the name of the table, which is the B there. Okay, right? And now once you have that, let's close the brackets again. All right, so now we have it fixed in the sense that at least, the NAs are no longer there, but we still have this redundant, first row, which we can then put a drop, so we can put a drop and say we want to just drop one row. So once we drop one row, we should be fine. So let's see where that is. This reduce, this is drop, good. And we drop what? One row, so that it drops that first row. And you can close the brackets here. All right, so now we have something that looks like it's working. Let's see. This is store 3, this is store B and store D. So let's change store 3 to no. Okay, so now we are left with just B and D, which is fine. Yes, B and D. If you change this to no also, then you have just store B. If you add store 2 there and make this a yes, so what you have now is very dynamic, data, which is based on, whatever the user chooses. At least gives you, quite some control. So the user just needs to include, the name of the table and choose a Y or an N, and that will get, consolidated and appended into your overall data that you have here. So that's what I thought to show in this video. I know the point for this, like I also alluded to in my first video, would go to Power Query, but it's good, to also see how you can do some of these consolidations, in Excel, using just formulas and taking advantage of dynamic arrays and the new functions that we have. And I would jokingly say that with this, I don't need to refresh, to have the data aggregated. It's a formula, and once anything changes in my table, the result, also changes. Thank you for your time. I hope you like this video. Please do hit the like button. You can also subscribe to the channel Excel Moments. For now, I'm out.